Hey guys, I don't want to make this video too long because this is just review. You don't have homework over this. This is all review for you, but it's important enough that when you come to class on Thursday, I need you to understand the language and the concepts. So in your journal, we have already glued this section down. This is the one that's talking about, it's the beginning of inequalities. And so you know what the inequality symbols are. If it's less than, it looks like that. Now when we graph it, a less than is an open circle on the graph. So I'm just going to put a colon, it kind of looks like a smiley face. Less than or equal to is less than or equal to as an inequality. And then when we graph it, it's a closed circle because it's equal to that. The greater than is greater than, but then on the graph it's an open circle, and greater than or equal to, again, is an open circle. So we have what it looks like in an inequality statement, and then what it looks like on a graph. So for example, I'm just going to do the odd ones right here for you. If it says graph each inequality, it's saying that x is greater than -8. So the first thing I want you to do is, if I give you a blank line, how we do that is we're going to put this target integer in the middle, -8. And then we're going to write 3 integers to the left, 3 integers to the right. So here would be -9, -10, and -11, and -7, -6, -5, because when we locate, 0 is on this side. What this inequality is saying is that this statement is are all numbers that are greater than -8. So it's going to be open circle because it's not, the solution cannot be -8, it's only numbers greater than. So when we graph it, we do an open circle, and notice my line is on the line, right here. I'm not graphing above it, I'm graphing on the line. That's because in upper school, that's what the teachers want you to do. They want you to graph on that line. So I'm training you now for what the upper school wants. Now, a couple of things about this. Here's a hint for you. Notice this arrow. When the variable is on the left-hand side, which we've been in training now, we've always trained ourselves to make sure we put that variable term on the left-hand side. And then I'm really a stickler, and I said use the symmetric property to make sure that variable's on the left-hand side. Well, now it's kind of cool, because look what happens. When that variable's on the left-hand side, notice this arrow, this greater than arrow, matches the arrow on my graph. So that's a quick check for you to make sure, are you graphing in the right direction? Well, if x is greater than, x is going to be greater on the graph, and those arrows match up, so you're going in the right direction. Okay, look at number 3. M is less than -3. So here's -3 on my number line, -4, -5, -6, -2, -1, and 0. This is saying that solutions to this, x is less than -3, that can include all integers on the left-hand side. So it's open circle and all these integers over here. So it can be -4, -5, -6. Remember, inequalities aren't equal because it's not just one answer. It's multiple answers. Actually, I said we were going to do 5, but I want to go over here to an equal statement. It says P is greater than or equal to 14. So my target integer is in the middle, 14, 15, 16, 17. And then 13, 12, and 11. So that's what my number line looks like. It's just a snapshot. So in this statement, it's saying that P is equal to 14. So if it is equal to 14, I'm going to shade that one, because that tells my graph, that tells the reader that 14 is a solution. And it's not only just 14, it's 14, it's 15, it's 16, it's 17. It's all numbers greater than. And notice my arrow is in the same direction. And notice on number 3, when m is less than, this arrow matches that same direction. Okay? So that's what it looks like when we're graphing. Didn't work. I thought it was. Oh, good. Okay. When we translate inequalities, it says a number, any number is less than 4. A number is less than 4. And then, of course, I can graph it. A number is at least 2. So here's a number, and I know my target integer is -2. And it's saying is at least -2. So here's what I have to do. I say, okay, if it's -2, it's got to be at least -2. So can it be -3? Nope, it can't be -3. Can it be -1? Yes, it can. It's got to be at least -2, so it's got to be x is greater than or equal to -2. Okay, because it can be -2 and anything greater than that. If a number is no more than 9, here's my number and here's 9. It can be no more than 9, which means it can't be greater than 9. It's got to be less than or equal to 9. And number 11, a number is at most 40. If a number is at most, it can't be greater than 40. It's got to be less than or equal to 40. Okay? So that's what the translating is. I didn't graph them because we graph them the same way as we would in examples 1 through 6. But if you want to fill that out in your notes and I can check them, that's absolutely okay. But I just don't want to make this video too terribly long. And when we talk about solutions to the inequality, all this is saying is that x is greater than or equal to -6. So if I were to graph that, here's -6, and here's 0 on my number line, right? And here's -12 all over here. If x is greater than or equal to -6, is 4 a part of this solution? Well, if I graphed it, it's all these integers that are greater than -6. So is 4 greater than or equal to -6? It is. So it is a state. It is. Yes. Yes, it is a solution. Okay? I can say 4 is greater than or equal to 6, and that statement's true. Look at number 15. Is 15 greater than 15? No, it's not. It's equal to. It's not greater than. Is 11 less than 8? So I'm plugging in that number 11, and I'm seeing, is this inequality statement true? Is 11 less than 8? No, it's not. So that's how we would do these guys when we're testing to see, is it a solution to the inequality? All right, when we solve for inequalities, there's this one big rule we have to remember. If you multiply or divide by a negative number, you must flip your sign. So if you multiply or divide by a negative number, you must flip the inequality symbol, okay? All right, so for example, number 18, and basically all that's saying is if your coefficient is negative, so what it means is if coefficient is negative, your sign switches. Your sign switches. So even before I go through these, I can see, is my sign potentially going to be switched? Is my coefficient negative? Nope, not going to flip that sign. Coefficient negative? Nope, not going to flip that sign. Is my coefficient negative on 20? Yep, I'm going to flip that sign. Coefficient negative? Nope. Is my coefficient negative? Yes, it is, so eventually I'm going to flip that sign. Number 23, my coefficient's negative. I'm eventually going to flip that sign. Number 24, it's positive. Not going to flip the sign. Number 25, I'm multiplying both sides by a -4 here to get rid of my fraction, so I am going to flip my sign. So let's go through some examples together. Let's just start, why don't we just do 22 through 25 just to refresh your memories because we're almost at 10 minutes on the video. All right, so number 22, remember we want to isolate the variable, so my first step is to get rid of this constant term, which is +4. So I'm going to subtract both sides by 4, and I get w over -7 is greater than 1. Now to get w by itself, I'm going to multiply both sides by a -7. Well, that's when a flashbulb goes off in your head. I'm multiplying both sides by a negative. I must flip this sign. So it's at this stage that I flip. So those cancel out to be w is less than -7. That's my inequality that I'm going to box, and then -7's here, so -8, -9, -10, -6, -5, -4. Open circle on -7, shade to the left, because this arrow matches this arrow. Okay. Number 23. Coefficients on the left, constant terms on the right. So I'm going to subtract 4, additive inverse. I get -3k is less than or equal to -27. To get k by itself, I divide both sides by a -3. And if I'm dividing both sides by a -3, flashlight goes off, I must flip my sign. So k is greater than or equal to 9. That's my inequality. Here's 9, 10, 11, 12, 8, 7, 6. close circle on negative 9 because 9 is a solution in anything to the right. Number 24. I'm going to add 16 to both sides. I get 3/8 is less than negative 9. Oh, 3/8 x. And to get x by itself, I use the multiplicative inverse. So I'm going to multiply both sides by 8/3. Multiply by 8/3. And remember, you should do this at the top of your head. 3 and negative 9 cancel out to negative 3. Negative 3 times 8 is negative 24. Remember multiplicative inverse here. I'm multiplying by a positive, so no need to flip my sign. So here's negative 24, open circle, shade to the left. And last one on 25. Here, I got to clear out my fraction first. So to clear out my fraction, I'm going to multiply both sides by a negative 4. I'm multiplying by a negative, so I must flip my sign. So p plus 9 is greater than negative 5 times negative 4, which is positive 20. And to get p by itself, I subtract 9 on both sides, and p is greater than 11. So 11 goes in the middle. Of course, I would number them. Open circle, shade to the right. Okay? So hopefully that's just a refresher. If you have questions on any of these notes, come and see me because you're still responsible for this stuff on a quiz or a test. But that should refresh your memory.